All right, let's continue our unit on congruent triangles and talk about congruent figures. Not just focusing on triangles, but any type of congruent figures. We've talked about the rigid motions, such as translations, reflections, rotations, that maintain congruence. So let's talk about some of the properties that congruent figures have. So we talked about figures being congruent before if they have the exact same shape and size. So these figures are congruent while these are not because they're different sizes or shapes. So if figures are congruent, all parts of the figure are congruent to the corresponding parts of the other one. So for instance, these corresponding sides are congruent. Corresponding angles are congruent. And in geometry, we can write congruent statements to compare them. So I could say triangle ABC is congruent to triangle FED. I could also say triangle BCA is congruent to triangle EDF. If I wanted, I could say triangle CAB is congruent to triangle DFE. We can label them any way we want. We just need to make sure that corresponding sides and angles match up. So I know that angle A is congruent to angle F, and angle B would be congruent to angle E, and angle C would be congruent to angle D. And I can tell by looking at my congruent statement. A is the first letter listed, so is F. So A is congruent to F. B is congruent to E. C is congruent to D. And then the corresponding sides, AB would be congruent to FE. In the same way, BC would be congruent to FD. And also, AC, or CA, it doesn't matter how we write it, would be congruent to FD. And once again, if I have the diagram and it can match up the sides, I can look at it. Otherwise, if I just have the congruent statement, I know that BC, the first two letters, match up with ED. And I can just look at any of the order there. And that's the importance of writing congruent statements in that manner. So go ahead and identify the congruent parts, pause the video, and write the statements accordingly. Okay, so you can see that the two figures are congruent. This one's just been rotated. ABC's been rotated over to triangle FGH. So ABC is congruent to triangle FGH. A is congruent to F. Angle B is congruent to angle G. And angle C is congruent to angle H. Once we know that, which angles are congruent, we could write our congruent statement. A is the same as F, B and G, C and H. And then I could just match up AB, first two letters, FG, BC, GH, CA, HF. Or if I need to look at the diagram, I can match them up as well. So now if we know DEFG is congruent to SPQR, let's say I want to find the value of X. X is part of this segment, 2x minus 4, so QR. Well, if I know QR is congruent to which segment? Well, QR is the last two, so it's got to be FG. Sometimes it helps to look at the lettering more than looking at the diagram because sometimes it's hard to figure out if it's rotated or reflected. So FG is 12, so 12 equals 2x minus 4. Those two are equal, so I can solve the equation, add 4 to both sides. So I got 16 equal to 2x. Therefore, x is 8. Okay, so I found the value of x. Now let's find the value of y. Y is 6y plus x is that angle, angle Q. Angle Q, I know, is same as angle F. So measure of angle F is equal to measure of angle Q. Find F. F is 68 degrees. And that's equal to 6y plus x. We already found x was 8. That gives us that equation. So I subtract 8 from both sides. I get 60 equals 6y. And therefore y is 10. Okay, so we can solve algebraic equations if we can match up what we know. for the congruent figures. Okay, so if I look at this diagram here of the wall divided into a section of orange and blue along JK, what will the sections of the wall be? Will they be the same size and shape? Well, we can take a look here. See, we have those two sides are congruent. These two sides are congruent. Those two sides are congruent. And we know this side is part of both polygons. And we've got one right angle. We've got another right angle. And since these two are perpendicular to each other, we know the lines are parallel. And if the lines are parallel, we've got a transversal cutting through here. Alternate interior angles would be congruent. There's a lot of markings, but we can tell now that since all angles, all sides are congruent, the two sections would have to be congruent as well. Let's talk about what's known as the third angles theorem. So let's just put that simply. Let's say that we have a triangle. Let's say this is 30 degrees. Let's say B is 70 degrees. Well, using what you know about the triangle angle sum, or the angle sum theorem, you know that C would have to be 80 degrees because 70 plus 30 is 100 plus 80 is 180. All three of those have to have a sum of 180 degrees. And let's say we didn't know this angle C yet, but let's say we knew that A and B were congruent to D and E. Well, that would mean that this would have to be 30, and this one would have to be 70 because they're the same. What would angle F have to be? Well, 30 plus 70 is 100. It's a triangle, so subtract the sum from 180. That would mean this would have to be 80. So I think you can kind of see that no matter what happens, if we have two angles the same and two triangles, the third angle has to be the same because there's only one possibility there. That's what this third angles theorem says. So if we use the third angles theorem, we can find the measure of angle BDC. I'll highlight it here. See if you can pause the video and figure out what that angle measure has to be. Okay, so if we take a look at angles that are congruent, we can see that if we look at triangle BCD, I have one of the angles and the second one. To find the third one, I just subtract that from 180. So that angle is 105. All right, now let's finish with a proof. This proof says that FH is congruent to JH. It's always important to write on our diagram so we know what we're talking about. FG is congruent to JG, and FHG is congruent to angle JHG, and angle FGH is congruent to angle JGH. And we want to prove that the two triangles are congruent. So if we want to do that, well, remember what congruent means? Well, all sides and angles need to be the same. So we're going to need to prove that this angle is the same as this angle. And we could use that by using the third angles theorem. So we could show that angle HFG is congruent to angle HJG. So we have that would prove all three angles congruent. We have two sides congruent. We just have to prove that side HG is congruent to itself because it's in both triangles. And we could use the reflexive property to do that. And if we do that, then we'd have enough information to prove that the two triangles are congruent. So taking a look at the blanks that we have here, FH, all this information here, that's given to us. So we can list all that right away. We mentioned, well, that gives us two sides. How do we prove the third side? Well, that would be side HG. We could say that's the reflexive property. We're just stating that HG is congruent to itself, but it's in both triangles. Next, we have the rest of the angles that were listed to us right away. Angle 1 and 2, and that also is given to us. And we want to prove that the other angle was congruent. So we said angle HFG would be congruent to angle HJG. By the third angles theorem. If two angles are congruent to the other two angles in the other triangle, the third angle has to be congruent. And if you don't like to say third angles theorem, you could say, well, if two angles are congruent to the other two angles in the other triangle, third angles have to be congruent. So don't worry about getting the wording down perfectly. If you have the idea or concept, you can just write that down. Now, if all three angles and all three sides are congruent in both triangles, we know the triangles have to be congruent. And we could just say that's just a definition of congruent figures. Because we've shown that all sides and all angles are congruent, we can therefore state that the polygons are congruent. So, we've learned how to work with congruent figures, how we can write congruent statements and show which angles and sides are corresponding and would therefore be congruent. We worked with some problems where we're setting up equations to find values. And we also learned the third angles theorem and wrote a proof using the third angles theorem and definition of congruent figures. Hope you had a wonderful time learning today. We'll see you later.